does it travel through the fastest and why? What does sound go through the fastest? Candy.
Water.
Goes through water the fastest? Try again.
Air.
Try again.
No.
Solid.
Good job, Cannon.
I completely choked that.
Oh, no, you're fine.
I thought I saw
I can explain
water.
it, Mr. B.
Jacob, you got the explanation? All right, why does it go through solids the fastest?
Because there's more particles for it to bounce off of to move quickly through it.
So there's more
They're closer together.
denser,
So you're telling me I had the right reason, but just like,
yeah, more denser particles that vibrate better. So solids have more particles, they're closer together, and they vibrate better than other things do. That's not to say sound travels well through all solids. There are some solids that do not vibrate well, and so sound doesn't travel as well through them. But in general, sound goes quickly through solids. After solids, it's liquids, and it travels slowest through gases. Again, there are some exceptions to this rule, but for the most part, this is what you find.
Do we ask what liquid to gas? Do we have to explain that too?
I mean, you should know the order. You should know solids, liquids, gases, as far as the speeds go. All right. Tree falls in the forest. No one's there to hear it. Doesn't make a sound.
Yes.
bro, this was taking me off. Yes, it makes a sound.
Yes, it does make a sound. Mia, why does it make a sound?
I didn't explain it because I didn't know how to.
You just assumed it did.
Yeah.
Okay.
Mr. Big-
Yeah,
Because.
go ahead, Grady.
I said, because air is not like the best
Well,
and like it gets dispersed.
so it is going to transmit sound, and that's because it is going to vibrate particles regardless of if you're there or not.
About the rest of the day. First, I just really appreciate students and staff, your cooperation and your responsiveness to the fire alarm and getting out as quickly, efficiently, and safely as possible. There's a reason why we practice these drills throughout the year, and it's for days like this. So really appreciate everybody's cooperation. We will be dismissing lunches here in the next couple minutes. And then teachers, we have turned off the bells at this point in time. So any cue for transition of classes, at least during the lunchtime, will happen over the PA. Okay, so again, any transition that needs to happen during lunches will happen over the PA. Teachers, you will be getting an updated schedule. Obviously, periods 5, 6, and 7 are going to be abbreviated because we're running probably 25 to 30 minutes off schedule right now. So we will make an adjustment and get that to you as soon as we can. We will continue with our normal lunch schedule, at least time length, so we can get through those, okay? So again, teachers, we'll get you an email here soon. I'll let you know when that goes out. And we will start dismissal from lunch here in just a moment, okay? Thank you again for your cooperation, and stay tuned for further updates. And also, there was just simply some smoke in our ventilation system. There was no fire, so everybody's safe. We're in good shape. Fire department was here, checked things out, so we are safe and good to go for the rest of the day. Again, thank you.
All right. All right, number 8, here's a lovely thought. So if you're out in space, you're not wearing a spacesuit.
You're dying.
No, well, okay, eventually. But no one can hear you scream.
I can tell you why.
I can tell you why.
I can tell you. Don't call on Jacob. Don't call.
Let's mix it up. Jackson.
Like that. And no one can hear you because there's nothing for it to like vibrate across against.
Beautiful.
Bingo. I'm glad you have Cannon's approval. That's what you really need. But yes, so there's no particles to vibrate in space.
I said infrasonic because that's what it said for like on the paper.
So infrasonic's a little different. So infrasonic is things that are lower than the frequency that you can hear. So regular sonic is from like 20 to 20,000. Infrasonic is under 20. So like for example, my giant wood tuning fork, I've calculated the frequency before. But the frequency of this is like I think it's like, gosh, what was it when I calculated? I think it's like 15 or something like that. So like, you can kind of hear like you can feel the vibration, but it doesn't really make a sound that you can hear. But you can see the vibrations, and so it is creating a sound. It's just not creating a sound that you can really hear or distinguish, just because it's a very, very low frequency.
Did you find that stick?
No, I had a student bring it in who found it in the woods.
And inside the bus. Okay, inside the bus.
Yeah. They brought it in, they're like, Mr. B, I found a tuning fork in the woods. And I'm like, that's actually helpful. So now I use it. I've had it for like, I bet I've had it for 10 years.
Did you offer us some cash for it?
Why?
Or was it just like, boom?
No, it was just out of his good faith and goodwill.
It's a dumb man.
Yeah.
I'm wondering what
So in space, no one's going to hear you scream because there's nothing to vibrate in space. So sound does not travel through space because there's nothing there. Which brings up this question, which is kind of interesting. Does the sun make a sound?
No.
Well, you can't hear it, but in theory it should make a sound. The sun should make a sound because it's vibrating particles inside the sun. The sun is creating particles, and there's a bunch of things vibrating, and there's flow of hot plasma on the surface, and so it should produce a sound, but even if it did, we couldn't hear it because it can't travel. There's nothing to travel.
So like, is wind like created from the motion of the earth? And, like,
Yeah, so wind is caused by a couple different things. So wind is caused predominantly by pressure differences. So you have like high pressure and low pressure, and so the wind will blow from areas of high pressure to areas of low pressure. And that has to do with temperature. When things heat up, you generally get lower pressure. When they cool down, you get higher pressure. And so that's where the storms come from. But there's also something called the Coriolis force, or the Coriolis effect, and that has to do with the rotation of the Earth. That's why storms usually come from the west. So storms come from Illinois, they don't come from Ohio. And the reason is the Earth rotates, and so the wind is blowing, but the Earth is also spinning. So the Earth traveling kind of makes it seem like things are moving, even though really they're staying still and the Earth is rotating under. So that's another cause.
So clouds never move?
No, they do, but they don't move. Like the Earth is also moving. It's not just the cloud moving. It's the
So
cloud
it's like-
moving and the Earth rotating. Something kind of like that. Yeah, that's why things usually come from the west. Like it's not impossible to have a storm come from the east, but very rarely does it come from the east. It's almost always it comes from.
Is that why when it
Like-
rains in Indiana, it usually rains in Ohio?
Right, because it'll go from us to them. Yeah. Yeah.
So if you were standing next to a rocket ship in space, you would be able to hear it?
Correct. Like if it's firing all of its rocket boosters, you wouldn't hear anything. Yeah, standing next to it. Unless you were to like put your ear on the actual spaceship itself, because then you could hear the vibrations through the spaceship.
Question.
Yeah.
So let's say boom, rocket,
Yeah.
but
Yeah.
you can't hear it.
Yeah.
If you touch it,
You'll feel the vibrations. You would be able to feel the vibrations, but you wouldn't necessarily hear anything.
so
You'd
it'd
have
be
to
like
put-
then.
something like that. Yeah, you would like feel. It's kind of like in baseball when you hit the bat and you can feel the vibrations. Because the bat is doing that same thing. It's causing that
At
oscillation.
12:30, I will be on the PA to dismiss you to go to lunch. So again, we'll dismiss to lunch at 12:30 for sea lunch.
So we're not looking for us to collect.
Gosh, this is gonna be dicey on my. I gotta get two tests this next couple of periods.
Oh, are you
That's
serious?
gonna be dicey. We're gonna have to jump right into those suckers. And then hopefully
Dosing?
Huh?
Do they have
No.
no?
Well, they do that usually, but today they're not going to. It's going to be like, sit down and do it. All right.
Go backwards.
All right, so
Quick.
Can I
yeah.
put one?
No, but I got to do 2 more tests.
Can I feel bad for the